Good morning, students. And the next unit 5. Okay, fifth unit. It is fifth unit is heterocyclic compounds, pyridine and piperidine, and 5 and 6 membered heterocyclic compounds. Okay, so we see about the heterocyclic compounds. Okay, so first the heterocyclic compounds here the cyclic compounds contain one or more atoms. Okay, here the cyclic compounds, it contains a 5 carbon. 1 2 3 4 1 2 3 4 5. Okay, 5 carbon atoms here. So here the 5 carbon atoms contain the cyclic rings which contains one or more atoms, which means nitrogen, oxygen, sulfur. Okay, so see the oxygen, sulfur, nitrogen. Okay, so these are the cyclic compounds, said to be cyclic compounds. Okay, so in this ring members, addition to the carbon atoms here, addition to the carbon atoms. Okay, here the one carbon atom here, by adding one nitrogen or oxygen except. Okay, so said to be heterocyclic compounds. Okay, so heterocyclic compounds are maybe 5 or 6 member. Okay, so here it contains 5 member ring, or otherwise it to be 6 member ring. Okay, it may be 5 or 6 member heterocyclic rings. Okay, so these are very stable and containing conjugated double bonds. Conjugated means here said to be conjugated. Okay, this is also conjugated double bonds. Okay, so it will be exhibit aromatic nature. Okay, first point, it contains one or more atoms of nitrogen, oxygen, sulfur. Okay, adding to the carbon atoms called heterocyclic compounds, where it is adding cyclic compounds. Okay, so heterocycles are 5 or 6 member heterocyclic ring which are stable and containing conjugated double bonds, and it is exhibit the aromatic character. Okay, double bond, it contains a double bond and aromatic character and becomes stable, and also it contains 5 or 6 member heterocyclics, and otherwise it contains one or more atoms of nitrogen, oxygen, sulfur. Okay, in the addition of the ring carbon atoms. Okay, is said to be heterocyclic compounds. So these are the example of heterocyclic compounds. Pyrrole. Okay, it is a pyrrole structure. Furan, thiophene, pyridine, pyrimidine, pyron, indole, quinoline, and isoquinoline. Okay, so these are the general definition of heterocyclic compounds. Okay, so these are the examples of this compound. Okay, okay, according to those, here the definition, the compounds like ethylene oxide or succinic anhydride. Okay, these are the compounds become, must also be, here also contains a heterocyclic compound, here also contains cyclic ring. Okay, but these compounds are less stable. Okay, so here these compounds, ethylene oxide, succinic anhydride, lactones, so these are also the heterocyclic, but they are less stable and the rings are open easily. Okay, so it becomes, does not possess aromatic, it is a aliphatic compound. Okay, coming on from the classification. Okay, here the classification. Okay, the first heterocyclic compounds classified the total number of atoms. Okay, here the total number of atom present in the ring. Okay, present in the ring, it is a first point. Okay, next it is divided into the number and nature of the heteroatom. Next will be, main classes will be divided according to the number, and again the nature of the heteroatom. Okay, it is a main point. First we see about the 5 member ring. Okay, first we characterize about the 5 member rings. Okay, 5 member rings containing 1 heteroatoms. Here it will be heteroatoms. Okay, because it contains 2 lone pair of electrons and all oxygen and sulfur. Okay, here the 2 lone pair of electrons here. Okay, so here also contains 2 lone pair of electrons. Okay, so it is an example of 5 member rings of 1 heteroatom. Here the 5 member rings contains 2 heteroatoms. So here 1 heteroatoms, here 1 heteroatoms, it contains 5 member ring. Okay, pyrrhozole, imidazole, oxazole, isozole, thiazole, isothiazole. It contains 2 heteroatoms, but it contains 1 heteroatoms. Okay, around the 5 member rings. Okay, it is a first number classification. And third, it contains more than 3 or 4 heteroatoms. Okay, here this 1, 2, 3 is said to be ozotriazole. Here triazole contain 3. Okay, so these are the examples of this classification. Next is 6 member rings. Coming out from the 6 member rings also containing 1 heteroatom, like pyridine. Okay, pyridine contains 1 heteroatom, and pyron. Okay, it contains 1 heteroatom, and other 2 atoms, pyridazine, pyrimidine, pyrazine. Okay, it contains 2 heteroatom here. Okay, so 2 heteroatoms in the 6 member rings. It is a general classification. Okay, so here the aromatic behavior. What are the aromatic behavior of the heterocyclic compound is indicated. This aromatic behavior indicate the stability. Okay, stability means high resonance energy. Okay, resonance, cyclic structure said to be resonance. Okay, so here the undergo electrophilic substitution, electron which contains one negative electrons. Positive substitution. Okay, so rather than the addition reaction, electrophilic substitution rather than the addition reaction. Further, these molecules are planar. It may undergo electrophilic substitution and become and high resonance energy, and molecules become planar. This is the aromatic behavior. Okay, it is a main point. Coming on from the examples of heterocyclic compounds. Okay, so these heterocyclic compounds obeying the Huckel's rule. Okay, so these are the compounds and the number of pi electrons present here. It is a n number of electrons. Okay, the number of pi electron here, n is a number, how many molecules are present in the heteroatom. Okay, here the pyrrhozole contains 6 pi electrons and number will be 1. Here the furan contains 6, again contain 1 heteroatom. Okay, 1. Okay, pyrophene 6 ring contains 1. Okay, number 6 pi electrons and 1. Okay, these are the example, so need not worry about this. Okay, so first we see about the pyrrole. Okay, coming to pyrrole is a preparation, properties and the mechanism, physical and chemical reaction and uses. So okay, so first we see about the pyrrole. It is a pyrrole structure. Okay, pyrrole structure, it is very important reaction. Okay, so pyrrole is a important 5 members heterocyclic compound. It is a 5 compound. It is a 5-member ring. Okay, because one 6 carbon will be removed in NH. Okay, because it is a nucleus occurs in the natural products. It is the naturally occurred compound. Okay, so to be chlorophyll, hemoglobin, alkaloids, etc. Okay, so it is a naturally occurred compound. Okay, so it is a pyrrole, 5-member heterocyclic compounds and natural products. Okay, naturally occurring products. Okay, so it is a main point. Coming on from the synthesis, very important synthesis. Okay, heating. Here the pyrrole is prepared by heating of succinic aldehyde with the ammonia. Okay, here the succinic aldehyde. Okay, here the succinic aldehyde reacted with an pyrrole in the presence of it getting pyrrole reactions and getting to H2O. Okay, so here the heating process, sublimation process happening in this reaction. Okay, so it is a pyrrole, it is a main structure. Okay,